Today we'll be working on lesson 4.8, solving radical equations, and we're going to start with this problem. Square root of 2p plus 3 equals 10. So remember, whenever we're trying to solve a radical equation, you have to isolate the radical. So as you can see, there's a plus 3 over here. You need to move it to the other side, so you have to subtract it from both sides. So you end up getting square root of 2p equals 7. So as you can see, you have isolated your radical. After you do that, you have to get rid of the radical, and to do that, you have to square it. Since this is a square root, to get rid of it, you have to square both sides. And this radical will be cancelled, and you will get 2p on the left side of your equation. 7 to the power 2 is going to be a 49. So you will end up getting 2p equals to 49. Now you need to solve this by dividing both sides by 2. So p is equal to 49 over 2. You can keep it as such in a fraction form, or you can actually find what the decimal number is. Now after you get your solution, remember you have to plug it in and to check if it's really a solution, if it really makes sense. So don't forget the last step. And the last step is going to be to go back to my main equation and to check if I plug in 49 over 2 for p, will I get a 10? So let's check that. Remember, 2 times 49 over 2, the 2 will cancel, so you're going to be left with just square root of 49. And copy everything else. Square root of 49 is a 7. So 7 plus 3 is a 10, which is equal to 10. So as you can see, it gave me something that's acceptable. So yes, p equals 49 over 2 is a solution. So remember that your first step is always going to be to isolate your radical. Get rid of the radical by squaring it if it's a square root. Then solve for p by dividing by 2. After you get your answer, remember to double check. So plug it in your main equation and see if it's going to give you something that's acceptable. Now there's another question, so I'm going to do this one for practice. Now 4th root of 2x plus 6 equals 2. So let's move on to this one. Remember, the same rules apply. You have to isolate the radical, but since the radical is already isolated, I'm going to try to get rid of it. Now, remember before we squared the radical because it was a square root. Here, since the index is 4, so you have to raise it to the 4th power to be able to get rid of the radical. So, since you raised it to the 4th power, the radical with the exponent, they cancel. So you're left with 2x plus 6 on the left side of your equation, and 2 to the power 4 is a 16. And you end up with this on the right side of your equation. Then you need to solve for x, so you subtract 6 from both sides. You end up getting 2x equals 10. Then you divide both sides by 2, and you get x equals to 5. And that's going to be the answer I got. But remember, once you get the answer, you always have to double check by plugging it back into your radical. So 4th root of 2 times 5 plus 6, is this going to give me 2? We're going to double check that. So 4th root, 2 times 5 is 10, plus 6, you're going to get 4th root of 16, and that is a 2. So this is my solution, x equals 5. Now let's move on to another problem, and now we're going to be doing this one. 7w plus 2 to the power 1/4 plus 2 equals 7. Now, you can do this in a couple of ways. So you can change from a rational exponent to a radical and solve, or you can actually solve it as a rational exponent. Now, what I'm going to do is I'm going to change into a radical form first. So remember, every time you have a fraction, the bottom of the fraction is going to be your index. So 7w plus 2, all of this to the power 1, plus 2 equals to 7. So copy everything down. Now, so as you can see, this number is going to be the power on the inside, and the bottom of the fraction is going to be your index. So you have 4th root of 7w plus 2 equals to 7. Now, to be able to solve this, you have to isolate the radical. So I get 4th root of 7w plus 2 is equal to 5. Now remember, guys, that you have to raise this to the fourth power since the index is 4 to be able to cancel the radical. And you raise the other side to the power 4 as well. So you're going to end up getting 7w plus 2 equals 5 to the power 4, which is 625. Remember, you're not allowed to use a calculator. And you subtract 2 from both sides, so 7w is equal to 623. Now when you divide everything by 7, because you need what w is equal to, and you get that w is equal to 89. And that's going to be your final answer. Now remember, you have to go back to your main equation and check it. So double check. 7 times 89 is 600 plus 2. This will give you 625. Now 625 to the power 1/4, it means you need to think of something that you multiplied by itself 4 times to give you 625, and that's a 5, plus 2, that's equal to 7. So that's how you do it, by changing it to the radical form. Now can I keep the rational exponent? Definitely you can. So let's see how we can do it. Now to do that, you can keep it in a rational exponent, and then you apply the same idea. You have to isolate the parentheses, so you get 7w plus 2 to the power 1/4 is equal to 7 minus 2, which is equal to 5. Now, in order to get to the inside, which is the w, I need to get rid of the fraction. So what do you think I need to multiply the fraction by to cancel it? If you multiply it by 4, the 4 and the 4 will cancel out, so you will get a 1. And whenever you apply to the left side of your equation, you also have to apply it to the other side. So you basically raise it to the fourth power. So what you do is you think of a number that would cancel out your fraction. 1/4, for this to cancel out, you have to multiply it by 4. And there you go. You only end up with a 1. And then it's 7w plus 2 equals to 5/4, which is 625. And you know how to continue from here. Now, so again, you can do it any way you like. Now, I would like to do one more example with you. So let's go ahead and try this number, or this equation. We're going to be doing square root of 2x plus 14 equals 2x plus 3. Now remember, as you can see, you have to follow the same rules all the way. Isolate the radical. The radical is by itself. Now to get to the inside of the radical, you have to get rid of the square root by squaring both sides. So when you square the square root, it cancels out and you are left with 2x plus 14 on the left side of your equation. Now on the right side of your equation though, you will get x plus 3 to the power 2, which you need to FOIL and get x squared plus 6x plus 9. Now a common mistake that a lot of students do is that they FOIL or distribute the power and they write x squared plus 9. Remember, you have to write this as x plus 3 times x plus 3 and actually FOIL it. Okay? Now when you get something like that, you see an x squared and an x, then you have to think of factoring. So you need to move everything to the other side of the equation. So let me move the 2x and move the 14 by subtracting them. So I end up by getting 0 on the left side of my equation. I get x squared plus 4x minus 5. So now you have to think of two numbers that would multiply to give you negative 5, but add to give you 4. And the two numbers are x plus 5 and x minus 1. And remember that that's equal to 0. So x can be two values in this case. X could be negative 5 or x equals 1. Now, as you remember, we always said that you have to always plug in your number into the main equation to see if it makes sense or not. So let's try plugging in negative 5 and seeing if this is going to give me an acceptable answer. Okay? Let's try x equals negative 5. So it's going to be 2 times negative 5 plus 14 equals to negative 5 plus 3. Now, if you try to do this work, 2 times negative 5 is negative 10 plus 4, that's the square root of 4. And negative 5 plus 3 is negative 2. Now, remember what we talked about earlier. A square root of 4 is only 2. It can only be a positive number, so that is not possible. So negative 5 is an extraneous solution. It's not really a solution. Okay? Now, think of x equals 1. Also, you need to plug it back in your main equation. So, square root of 2 times 1 plus 14, and you need to check if it's going to give you 1 plus 3. So the left side is going to be 2 plus 14, which is a square root of 16, which is a 4. And the other side is going to give me 4. As you can see, they are equal. So yes, x equals 1 is one of my solutions. Now, to better understand this, you can go to your calculator and try to graph it, or you can just think of it this way. Square root of 2x plus 14 is probably going to be having an endpoint of negative 7, 2, or negative 7, 0. So it's going to be somewhere over here. It's going to be a shooting star. Now, the x plus 3 is going to be a line, okay? Let's say that this is the line. And it's going to touch my radical in only one point. So as you can see, I should only have one solution. Now, the reason why I do have a second solution when I'm solving or when I'm factoring, you got two of them. Because remember that the radical, if you take the whole inverted parabola, it's going to be cutting the straight line in 2 points. But my radical function is only the shooting star, it's not both of them. So, as you can see, my real radical function and my linear function x plus 3 only meet at 1 point, and that's why I only have one solution, which is 1. This one, which is the negative 5, is not acceptable because this part is non-existent, okay? Because we are taking the radical function over a certain domain and a certain range, okay? So remember to always plug in back after you're done. Now that's everything for today. I hope this video was helpful.